Hello everyone, welcome back to this tutorial series on object-oriented design using MicroPython. This is our 10th episode, being a milestone episode of some sort. We're going to actually build our first application, gadget that acts as a simplistic but fully functional networked weather station. So as you can see here in my little kit, I'm showing the outside temperature and humidity that updates itself every 30 seconds or so. So this is what we're going to build. We already have, last week we saw how to use a display. So we're going to use that, and we will use a new class that I will introduce today on how you can use a Raspberry Pi Pico W or a 2W to connect to the internet. So for this tutorial, if you're using a device, you will need one of the W version of the Raspberry Pi Pico. That's the one that has the Wi-Fi capabilities. So you will need that to connect to the internet. If you have the regular Raspberry Pi Pico, don't worry. In the next episode, we're gonna add local weather features to our Raspberry Pi Pico. So that one can be used without a network. So let's get started. As with all of our object-oriented design applications, we start with a design. So this is the design of our weather station. So at the center of it is a class that we call WeatherStation, and I'm going to show you how we create the code for this weather station. It basically needs two attributes, connection to the network and a connection to an LCD display. Today, we're going to keep things simple and just have these two things to our weather station. We will initialize the weather station with the init construct, probably send the create either connect to the network first and send an instance to the network to the weather station, or have it connect to the network itself. However way it is, you're going to initialize. Then in the weather station, there's just two simple methods. One that retrieves the weather forecast from the internet. And then the second one is it takes the weather that has been retrieved and shows it on the display. That's basically it. So the first thing that we're going to look at is this network class that's new. And it has a whole bunch of different methods to work with the network. I call it net because it's not just a local network, but also an internet class. So just for simplicity's purposes, this class is called net. But really, there are all kinds of methods in here. We're not going to go into all of them. The two that we will use today are what is in the design. The first one is a connect method. Of course, in order to use the network, you'll have to connect to the Wi-Fi network. And to connect to a Wi-Fi network, you need its SSID and password. So these Raspberry Pi Pico devices, they obviously don't have a full operating system. They don't have a web browser. So you can only connect to a standard Wi-Fi access point, for example, your home Wi-Fi network, or turn your phone into a Wi-Fi hotspot, and you should be able to connect your Raspberry Pi Pico to it. So you will need the SSID of your hotspot and the password that you assigned to the hotspot. And then the network class also has a method called getJSON, which takes the URL of an API, which you can use with a GET protocol. We will probably get into the details of protocols and things like that later in this tutorial. But today, it suffices to say you have an API that you use a GET request with some parameters, and what it sends back is data in JSON format. So I'm going to talk about the API that we're going to use today, and that's a very popular weather API called Open-meteo. And this is free. You can easily go into it, and you don't even need an API key for normal non-commercial access. If you want to use for commercial access, they have plans that you can sign up for and get an API key for that purpose. And if you want to set up your own little weather station, you do not need an API key. So the GET request that this API uses looks kind of like this. There is a whole lot of documentation under API docs on this website, but we really need to know what the endpoint is, which is basically openmeteo.com/v1/forecast, and you send in these parameters, latitude, longitude of the location for which we're requesting the weather, and then you can say whether you want the current conditions or if you want the hourly forecast and what types of things they want for the conditions and so forth. That's it. I have requested the forecast for this latitude 40.7, longitude minus 74.0, which is 40.7 north. So that's why it's positive. If you're on the southern hemisphere, you will say minus something. Same with the longitude. If you're in the eastern side, say positive, and if you're in the western longitude area, you say negative. So this is in 74 degrees west, so it is longitude is minus 74. And I'm requesting the current temperature, current humidity, and I'm requesting the unit as Fahrenheit. So that is basically what we are requesting from this web service. And what the web service gives back is something that looks like this. This format is called JSON. This is JavaScript object notation, and it's essentially a dictionary where it gives you the values of latitude, longitude, different things like time zone, etc., etc. And then since we have asked for current conditions, it sends back the current time units, the current temperature. So these are the units. And then the actual current time, the current temperature, and the current relative humidity. So these are the things that come back from the web service. Of course, the more you ask for, the more you get back in return. But for today's weather station, all we need is the temperature and humidity so that we can show it on the display. So let's take a quick look at the code. But essentially, if you recall, all we need to do is create these two methods. Retrieve weather, that's the one that connects to the API and gets the data back. And the second one is the show weather that basically talks to the display and shows the information on the display. I do want to show you a little glimpse of the sequence model for this. Now, the sequence model is not complicated, where here is the actor, which is basically the person whose weather station it is, who's turning it on, and it's going to then send a request to the network to connect to the network. Once it's connected, sends a request to the weather station to show the weather, and that is going to then call retrieve weather. It's a self call because retrieve weather is also another method in WeatherStation. And that method is going to, again, go back to the network and say, hey, give me the weather information. And that get JSON method then sends a call to the Open-meteo web service. This part is, of course, not in our code. This is handled by the Open-meteo web server. And that gives me back the JSON data, which I then send back to the weather station. Weather station can then just parse that data and pull out the temperature and humidity and call the show text method in the LCD display to show it. So this is the flow that we want to implement. And watch how simple it is to do that in object-oriented design. Net and display are already implemented. They are part of the library. We don't need to worry about those. Obviously, we also saw Open-meteo, how it works and how it gets those weather information. That's not our headache. All we want to do in our weather station is make sure that we can retrieve this information from the API and display it on our display. Now for the simulator, we do need to use the Pico Wi-Fi, the Pico W version. Walkway Simulator does have sort of a better version of the Raspberry Pi Pico W, and it does allow you to connect to the internet. So in order to do this, what you typically do is, you need to have a user SSID and password. You typically do not want to put the SSID and password in your regular Python source code. You typically create a separate file like parameters.py or secrets.py. So I created this secrets.py file, which basically has the SSID, which inside the walkway simulator, the SSID is called walkway dash guest with all capital letters, and key is empty string. And I'm also adding the latitude and longitude of the place where we want the weather station to retrieve the data from. So now that we have that, let's go to the code and take a look at our weather station code. So basically, as the design shows, it's got an init, takes in a network, checks to see if the network is connected. If it's not connected, then let's connect it. And then create the display using the SDA and SCL. And here I am creating a shape. We talked about shapes in the last video. Here I'm creating a degree shape. The degree, the symbol is not part of the regular text. So we need to create it as a shape. So I'm going to add it to the first position 0 as the degree shape. And then on the display, I just show a simple message saying weather station with the current IP address of the weather station. Let's take a look at retrieve weather. This is the one that is going to connect to the API, retrieve the data, and parse the temperature and humidity and send back. So it's basically going to take the latitude, longitude, and the unit to display in, and it returns back a tuple containing a temperature and humidity value. Right. So here is our base URL, which is basically what we saw, a V1 forecast, and I'm passing in the current temperature and relative humidity as our parameters that we want to retrieve. And in addition, what we want to do is we want to send in other parameters like latitude, longitude, and the temperature unit. Those three we are getting from the parameters to this retrieve weather method. Now, once we have constructed the URL, we call getJSON to get the response. And once we have the response, we can pull out the temperature, we can pull out the humidity, and return those two back. As you can see, just a few lines of code that lets us connect to an external API and then get the information that we want. And in show weather, all we are doing is self-calling. So I'm calling self.retrieveWeather. That's what that self-call was. Self-calling that to get the information back, and then just clearing the display. And on the top line, showing the temperature, and on the bottom line, showing the humidity. Notice that the top line is 0, 0, which is the default. And bottom line, the row becomes 1, so it goes in the second line. And notice that after the temperature, I'm showing CHR0, which shows the degree symbol. So let's see how this works on the simulator. There you go. We're trying to connect. And now that it's connected, it shows the IP address of the weather station, and it's connecting to the Open-meteo API now. Once we get the data back from Open-meteo, takes a few seconds in the simulator. And notice that here we received the data back from Open-meteo, just like what we saw in the web browser. Here is the data that came back. We parsed out the information that we need, and we're showing the temperature and humidity on the display. Pretty simple, but that's exactly what we saw in the hardware. And that's how you create your weather station. So if you have object-oriented design, one of the nice things about it, and we're going to learn more as we go in through this tutorial, is that you can basically build based of things that you already have access to. And that makes the design a lot simpler since we do not have to worry about creating information of the display and the creating information for the network. We just use classes that have already been created. So our code stays pretty simple, just a few lines for retrieving the weather and a few lines for showing it on the screen. Hope this was useful. This is how you build your weather station. As we go along, we're going to be going more depth into sensors and event handlers and things like that that will make this weather station a lot more useful. And I look forward to seeing you at another video. Thanks for watching.